Let's revisit our original task, our original goal for this notebook. We said we want to train a classifier to discern word usage. Specifically, the example we gave out was, can we train a classifier that can take a use of the word Python and determine whether it refers to Python the animal or Python the programming language? For natural language processing, we need a body of text, right? We need a corpus for our analysis. So let's go ahead and get a corpus for our task at hand. So what do you guys recommend? What are your suggestions? What are your thoughts of getting some corpus, getting a body of text for analysis? Remember, what we got to do is we got to get some observations. So one way we can do, one method is, let's go ahead and look at Wikipedia articles. And the reason why we want to look at Wikipedia articles is because we look at the Wikipedia article for Python the programming language and Python the animal, and combine those two articles as our corpus. And the reason why we want to do this is because if you want to do supervised machine learning, we have to have a dataset X along with the labels for all our observations. So we haven't discussed how we're going to generate documents from our corpus, but at the moment we understand that documents that are derived from Wikipedia article for Python the programming language will have a label of the programming language. In documents derived from Python the animal, is going to have the flag or the label of Python the animal. We can easily mark up our corpus, all the documents in our corpus, to have a label value. So we can use that data to train a supervised machine learning model, specifically a classification scheme. So let's go ahead and see how we can get our corpus. Now we're going to work with the articles of Wikipedia, so we can go ahead and go to Wikipedia. We can go ahead and say Python. Let's see what articles we see. So we see different articles. So we're interested more in Python the programming language. So we want to get the entire text from this page. Now the naive approach is to copy and paste. It's tedious. It's going to take a while. We can't automate that. It's very difficult. A second approach is we can use some scraping tools. There's a Python package called Beautiful Soup. You can do web scraping. Basically, you can take an HTML file and parse it and pull out the documents, pull out the sentences in our article. Now that we can automate. But there's going to be some upfront cost to writing the functions, the programs to do the scraping. So it's not ideal, but we could do that. But luckily for us, there is a Python package called Wikipedia. This Python package will allow us to get those Wikipedia articles very easily. So no need to copy and paste, no need to do any web scraping. We're going to rely on this Wikipedia package. So import Wikipedia. We're going to define a function here called pages to sentences. And our choice here is we got to decide with our corpus what's going to count as a document. Remember what a document is going to refer to for natural language processing. What does a document mean specifically in the field of natural language processing? It's going to be different than the way we use the everyday usage for document. Document's going to refer specifically to the unit of analysis, what's going to count as a single observation for our task. So what we're going to do is we're going to break down our article into the sentences. So we're going to look at all the sentences that make up our article. And each sentence is going to be a document, is going to be an observation. And we know what the label is for all our observations, because if it came from Wikipedia article for Python the programming language, it's going to have the label of the programming language. And if it came from the article for Python the animal, then the label is Python the animal. So we can mark up our text and have those labels so we can use for supervised machine learning. Let's explore this Python package, Wikipedia. So we have a function here. It's going to accept the pages. So there's going to be a string. It's going to refer to the page. We're going to have a list here called sentences. What we do for each of those pages, we're going to pass to the function. We're going to use the page function of the Wikipedia package. This is going to get the article. NP content is going to return the string of the contents of the article. And we're going to pass that string into the natural language pipeline here. That space is going to provide. This returns a doc object. So once we have that doc object, we can iterate through and look at the text for all our sentences. So that's what we have here with our doc object. We're going to iterate through the sentences of the doc object. So we're going to use a sense generator, and we're going to look at the text for that sentence. We're going to put it into a list, and we're going to augment our list. So essentially what's going to happen, what this function is going to return to us, is a list where each sentence is an element of the list, which is now getting into a more structured format. Right? Remember our goal here, we understand that we're working with text. It doesn't have a defined structure, and our ultimate goal is to generate a feature matrix, a matrix of rows and columns. Rows and columns that we can feed to a machine learning model. And so right now, each observation is going to be a sentence, so each element of our list is going to be a sentence. So that's what this function is doing. This function has the capability to go ahead and use more than one article. If you look at the length of those articles, the Python programming language article is a lot longer than the reticulated Python article. So for our text, what's going to serve as a corpus or marked up corpus for Python the animal, we're going to use two Wikipedia articles. The one for a reticulated Python and the ball Python. So this is going to produce two lists. We're going to combine the two lists. We're going to use a plus operator here. So now we have an object called documents. It's going to have a list. It's going to be a list of all the sentences in these three articles. So let's examine our language sentences and our animal sentences. Let's run this there. This might take a while as it has to grab them. Okay, so there we go. So notice we easily grab those articles. So here we printed out, looks like the first 5 sentences in the programming, the sentences for Python, the programming language. So we say Python is an interpreted high-level general-purpose programming language. So fourth, we look at the animal. We see it refers to text of the animal. So given what we have here, given the snippets that we're showing you, what patterns should our word usage classifier learn? Looking at this text, what do you think, generally speaking, overall speaking, not looking for a specific answer, but what are certain patterns, certain behaviors that we want our classifier to exploit with the data we have here? Well, let's look at the words. Let's look at the words that are associated with Python, the programming language. We see things like programming. We see things like code and programming once again. Maybe language, type, memory. Do you think those words that I just highlighted right now, do you think they're going to appear very frequently in documents that refer to Python the animal? If we look at a set of documents referring to Python the animal, do you think we'll encounter at a high frequency things like language, programming, high level, memory, object, procedural, library? Not so much. those words are going to have a very low frequency. They're not going to appear, not going to be very common when we have documents referring to animal, Python the animal. And the other ways around as well. If we look at documents for Python the animal, we examine it. We see things like South Asia, species, reptile, snake. Those words, yes, they might appear in documents for Python the programming language, but not a very high frequency. Not going to be very common in those documents. So we can see here is some way in which our classifier can exploit some pattern, some structure that our model can exploit to differentiate between the word usage. Is this Python the animal or Python the programming language? In the next few sections, we'll talk more specifically about those algorithms, that processing that needs to be involved to get what we have here into a ready format for a machine learning model to ingest. Let's look at the other question I posed. In this example here, we decided to choose our sentences to be each document. So each sentence is a document, is an observation. But we could have chosen something else. What are some other options? What could we have decided is going to constitute a document in our analysis? We chose sentences. What are some other options? Well, we could have chosen something longer. We could have chosen paragraphs. We could have said that each paragraph is going to make up a document. Or we could have increased it. We could have said a Wikipedia article could be a document. But what is the problem with saying, let's go ahead and make a Wikipedia article a document? One single observation. What are some pros and cons, right? There's going to be some pros and cons. So what would be a major con of deciding to set each Wikipedia article as a document? Well, if that's the case, then at the moment, we're going to only have 3 observations. We're only using 3 Wikipedia articles. So we're going to have to rely on a lot of different articles. And that's going to be hard to get. And we understand that these machine learning models are going to generally perform better when we have a large number of observations. So let's go ahead and break down that article. And we can say, well, let's examine sections within the article. But we're going to run that same problem. Those sections are not, there's only so many sections in each article, so the number of observations will be very small. But a pro, if we had chosen our document size to be an article or sections, is that there's a lot of information. There's a lot going on in an article. We're less susceptible to randomness, more information, so that's a pro. But the number of observations will be very small. We can use paragraphs. We could have chosen paragraphs as our unit of observation. What's going to constitute a document in our analysis, an observation. But using paragraphs, we're going to run into the same situation too. There's probably perhaps not too many paragraphs in our analysis, not too many paragraphs in our articles, so we're going to have a very limited number of observations. There might be more signal if we look at the paragraph level, but there might be some problems there. So we decide to use sentences as our document. Sentences, each sentence is going to constitute an observation. If we had more articles, then perhaps we could have said, you know what, since we have a lot of articles, we have a lot of text in general, let's move away from sentences and use paragraphs as my observation. So you can think of here as some parameter I can play around with for my analysis. We can always explore and use paragraphs, but for our analysis, let's just stick to sentences. Each sentence is going to be a document, an observation in our analysis.